Hey everyone, this is 2.1 Intro to Equations. This is also your intro to algebra, so I want to tell you briefly a little bit about the history of algebra. It's an Arabic word. It was invented by an Arabic mathematician named Al-Khwarizmi in 800 AD, and he wrote the phrase or the term algebra. And in his title of his book, it had something to do with completing and balancing. And so that's why I have the scale up here, and I'm going to use this kind of as an analogy for a little bit to make you think about an equation as a scale and keeping both sides balanced while kind of chipping away at the answer. So here's a couple quick kind of straightforward ideas or examples. If you picture this is our equal sign here and this is an equation, we could have 2 plus 3 equals 5. Scale is nice and balanced because those two things are equal indeed, right? 5 equals 5. Now you might be given an equation like this, x plus 3 equals 5. And when we say solve this equation, all we want is we want a value for x, or we want all values for x, because sometimes there might be more than one. We want all values for x that make the equation true. Well, obviously this is saying what number, when you add it to 3, gives you 5. Well, we saw already that number would be 2. So the solution to this equation would be x equals 2. Right? The solution would be the value or values for x that make the equation true. That's our whole goal. Anytime you're solving an equation, that's what you're looking for. This is a simple equation where you can kind of look at it and see the answer, but the whole point of algebra is if I give you an equation, which I can, that is complicated and you're not going to be able to look at it and come up with the answer, algebra is the method and the system of chipping away at the equation to get the answer. Here's another example. X plus 2 equals 10. Now you can do this in your head, right? Obviously 8 plus 2 equals 10, so our answer should be 8. But I want to show you what the algebra steps should look like, and I want to keep you thinking about this scale. So if I was going to do the algebra to solve this, you will always want to get x by itself. And right now, x isn't by itself because it's being added to 2. But if you want to get rid of that adding 2, you always do the opposite. So since I have a plus 2 there, what I can do is actually do a minus 2. Because minus 2 and plus 2 cancel each other out and leave you with x, right? But here's the problem. This was a balanced equation, and I just changed one side. So technically, I've unbalanced it, right? This side is actually going to be lower now. This side would go up because I decreased it. But I want to keep it balanced because I want to be able to find the correct answer. So all that means is I have to do the same thing to both sides. So that's the first idea of this scale, is whatever you do to one side, you have to do the exact same thing to the other side. Now again, we were subtracting 2 in this case because that's the step we needed in order to get x by itself. We had a plus 2, and you always do the opposite. Plus 2 means we're going to do a minus 2. Those cancel out, and so our expression at this step is x on one side, right, because the 2 is canceled. And over here, a negative 2 and a 10, we're basically doing like, you can think of it as 10 minus 2 or a negative 2 plus 10. Those are both the same thing. That would give us an 8. So like we said, that's how we solve it. And this is kind of what your steps are going to be looking like, right? Here's a couple more quick examples like that, just using fractions and decimals. Remember here in part A, x minus 1.2 equals 3.4. We want to get x by itself. It's not by itself because of the minus 1.2. How can we get rid of a minus 1.2? Well, we need to add 1.2. Right? It's always the opposite. Those two cancel each other out to leave us with x, which is what we wanted. But remember, you can't just do it to one side, you have to do it to both sides at the same time. So if I add a 1.2 to the other side, I get a 4.6, and that ends up being the answer, right? That is the value, right? That's the value for x that when you subtract 1.2 from it, right? If you subtract 1.2 from this, you get 3.4. So we're just finding the value that makes it true by doing the opposite, getting x by itself. Same idea down here, we have 1/2 plus x. The 1/2 is what we have to get rid of, and since it's positive, we're going to do a minus 1/2. We have to do it to both sides. These cancel out to leave us with x, which is what we wanted. So we just have x equals. And then 3/2 minus 1/2 gives us 2/2, which is just 1. So we get x equals 1. So far we've solved equations by doing the opposite, which would be adding or subtracting, but often the opposite is also multiplying and dividing. In this first example, x isn't by itself because it's being multiplied by negative 3. Don't forget, numbers next to variables mean multiplication. So this is negative 3 times x. If we want to get x by itself, the opposite would be dividing by negative 3. And again, you have to do it to both sides to keep it balanced. the negative 3's cancel, right? Because anything over itself cancels, and it leaves us with x equals, and 9 over negative 3 is negative 3. So that's our answer. And again, this makes sense because negative 3 times a negative 3 would be positive 9. And all we're saying is, when x is negative 3, we get positive 9. Same thing down here. This time x is being divided by 4. We want to get rid of that 4, so we'll do the opposite. We'll multiply both sides by 4. Here the 4's cancel, right? 4 over 4 is 1. So we get x equals 4 times 2, which is 8. And again, this makes sense because you can see 8 divided by 4 does give us 2. Okay, so basically what we've seen is that you can multiply, divide, add, or subtract numbers as long as you do it to both sides of the equation. And you do it so that you always do the opposite of what you have so that you can get x by itself. One other thing about fractions, technically here 3/4 is being multiplied by x, and we could get rid of it by dividing by 3/4, right? Just like we did anytime you do the opposite of what you have, basically. But dividing by a fraction is the same thing as multiplying by its reciprocal, like flipping it, right? Remember how you divide fractions. So in this case, it's actually quicker to go straight to multiplying by the reciprocal. The reciprocal means you flip the fraction, so I'm actually going to start by multiplying both sides by 4/3. Now notice over here, the 4's cancel, and the 3's cancel, and it just goes away and you just get x. That's the whole idea, right? We're just skipping that division step and going straight to multiplying by the reciprocal. And over here, if you think of this as 9 over 1, the 3 and 9 cross cancel, you get what? 3 times 4, you get 12 over 1, which is just 12. Okay, so that's a trick you can do with fractions. If you have a fraction multiplied by x, or your variable, you can get rid of it by just multiplying by the reciprocal, which is technically the same thing as dividing by the fraction. Another trick you can do with fractions is if you have an equation like this where you have a bunch of fractions going on, you can always start an equation, you can always start your solution by getting rid of all the fractions if you multiply all sides by the lowest common denominator. In this case, 2, 4, and 4 are denominators. The lowest common denominator would be 4. So if we multiply everything by 4, we should be able to cancel out all of the denominators. So let me show you what that looks like. Now over here, notice we're going to distribute. So just so this is nice and clear, I'm going to split it up. 4 times 1/2 x plus 4 times 3/4 equals negative 1/4 times 4. Right, so basically 4 is going to everything. Now what's going to happen is we're going to basically cross cancel with these denominators. Like over here, the 2's cancel, and it'll leave you another 2 there. So this first piece becomes 2x, right? Because 4 times 1/2 is 2, and we get 2x. This next one, the 4's cancel completely, so we just get a plus 3. And on this last one, the 4's cancel, but we have a negative, so it's actually going to be a negative 1 left over. Alright, so all we did is we multiplied everything by 4, we did all the canceling, and now we have an equation with just x's in it. Okay, and we'll talk about how to solve that later, but the whole point here is that anytime you have an equation with fractions, you can technically get rid of those fractions in your very first step just by finding the lowest common denominator, or technically any common denominator. Like I could have used 8, for example, and I still would have canceled. I just would have had like 4x plus 6 equals negative 2, something like that. We can do a similar trick for decimals. We just need to multiply by a power of 10 in order to get rid of the decimals. Because remember, when you multiply by 10, it just moves the decimal to the right. So for example, if I take 1.2 and multiply by 10, the decimal will move to the right and I'll get 12x. Now, that won't fix this one though, right? Because if I multiply by 10, I'll just get 21.1. I need another 10 to make it 211. That means I'm going to need 2 powers of 10, which is 10 times 10, or 100. I have to do the same thing to everything though, so what I'm going to do is multiply everything by 100. 100 times that, 100 times that, 100 times that, right? So this first one, decimal goes twice to the right, we get 120x. Second piece, decimal goes twice to the right, so we get 211, and 5 times 100 is just 500. So just like the last example, we can do a step from the beginning and multiply everything by powers of 10 in this case to get rid of all our decimals. You don't have to, you could stick with the decimals if you want, but most people will get rid of them if they can. Well, that's 2.1, Intro to Equations. Let me know if you have any questions, and keep up the good work.